Dr.R.J.Shelke, working as an associate professor in electronics department at Walchand Institute of Technology, Solapur. In the previous video, we are discussed with a helix traveling wave tube, part 1 as its construction part. In this video, we are going to discuss with the part 2 that is working of the traveling wave tube. Learning outcomes. At the end of this video, students are able to understand the needs of slow wave structure, explain the working of helix traveling wave tube. The contents which will be covered are introduction, needs of slow wave structure, working of TWT, some applications are also discussed, and the references. In the previous video, we are seen with the introduction of the TWT, what is the TWT tubes are said to be and its construction. Let us recall. The traveling wave tube is nothing but a vacuum tube which is used to amplify the radio frequency signal at microwave range, that is in the range of gigahertz frequency. These tubes are said to be or known to be a non-resonant tube structure because they offer a interaction of the RF field and the electron beam throughout the entire length of the tube. This is a slide which we are seen in the previous video also, which consists of a constructional part of the TWT tube. The various parts are being indicated over here. What are the different parts of the traveling wave tube? Out of this, we had discussed the construction part in the detail in the previous video. In this video, we are going to see the working of this tube. Let us, before see the working of this tube, let us, we are having the, recall a slow wave structure. What is exactly the function of the slow wave structure? What is the need of using the slow wave structure in the TWT? As we know that the velocity of electromagnetic wave is much higher as compared to the physical phase velocity of the electron beam which is emitted from the cathode through the electron gun. Basically, the RF field applied at the input of the TWT is with the speed of 3 × 10⁸, that is the speed of the light, while it is propagating velocity of the electron beam inside the tube is comparatively smaller than the velocity of the RF. Therefore, there is no matching between the speed of the RF field as well as speed of the electron beam. So, to reduce the speed of the, to accelerate the electron, because the electrons are going to give up the energy for the amplification. So, to accelerate the electron beam, then it is necessary to accelerate only to the fraction of light. So, it is better to reduce. The speed of the applied RF field in order to match the velocity of the electron beam. For this purpose, we are using the slow wave structure in the TWT tube, which reduces the speed of the RF waves inside the TWT. There are various types of the slow wave structures available, like single helical structure, double helical structure, zigzag helical structure, concrete, coupled cavity or ring bar. In this video, we are going to discuss with the single helical structure. The single helical structure is formed by weaving a wire of elements like tungsten or molybdenum in the form of the coil. The helical shapes, these helical shapes slow down the velocity of the RF field or a wave traveling in this along the axis to the 1/10 of that speed. Due to this, the wave traveling due to the slowdowning of that wave, the wave will travel with a longer distance than compared to the previous speed of that, and it travels with the along with the beam inside the tube. The speed of the wave propagating depends upon this speed of the wave depends upon the number as well as the dimension of the turns which are being used to design the helical structure. That is, it depends upon the pinch of the helicals of the wire, on which a speed of the wave propagation depends. So we said that the speed of the wave propagation depends upon the numbers of turns as well as the dimension of the turns. So the equation we gives shown below gives the relative phase velocity of the wave with the pinch of the helix. Here we are calling the phase velocity will be now Pc by pi d. What is P? P is nothing but the pinch, that is the distance between the two rings of the helical structure, while C is the velocity of light and D is a dimension of the diameter of the coil. As due to this helical structure, this causes a continuous interaction between the RF field and the electron beam, because the speed of the RF field is being reduced due to this helical structure. It will be near to the speed of the electron beam. In such an interaction, it will help in explaining the working of the TWT too. Let us see the working of the TWT tube. As you know that the RF signal which has to be amplified is applied at the one end of the helical structure. The applied RF field will produce the electromagnetic field inside the tube. These electrons which are moving along the helical path, which are emitted from the cathode, come into the interact with the RF signals in the helical structure. The electrons which are affected by the positive cycle of the RF field will get accelerated due to the positive field, while the electrons which are coming in contact with the negative cycle of the RF field will get deaccelerated. This acceleration and deacceleration of the electrons lead to the causing of the bunch formation, because the speed increases and the decreases. Due to acceleration, its speed increases, and due to the deaccelerating, the speed decreases. The electrons will come together and form a bunch. And this changing of the speed of the electrons is called as a velocity modulation. Thus is said to be a velocity modulation because the electron of the beam are being experienced with the different velocity inside the tube. However, the slow wave inside the tube exhibit the continuous interaction of the electron beam. Due to this continuous interaction, the electron moving with the high velocity transfer the energy to the wave inside the tube. As these electrons are the DC, they give up the energy in a form of the AC signals and thus slow down. This rises the amplitude of the wave. This energy is utilized to rise the amplitude of the wave. The velocity of the electron beam will reduce, and this will causes a bunching of the electrons inside the tube. Thus we say that velocity modulation and bunching of the electron takes place along the axis of the helix. Here you can see that initially the RF field which are being accelerated, RF electron beam which are accelerated electrons traveling into the tube are coming with the effect of the different RF field. The bunch of the electrons will give up the energy, deliver the energy to the wave, and the resulting of this will be the amplification formation. Thus the growing amplitude of the wave result causing the more bunching of the electron, while reaching at the end of from the beginning. The output whatever we are receiving at the end is an amplified output. Thus, it is concluded that no resonance structure is present in the interaction space. Thus, is provide the amplification up to the wide bandwidth with the operating range for the operating range. These are the few applications of the TWT. The first application, it is in the medium and high power satellite transponder, in wideband communication links, in continuous radar and the radar jamming on the land, aeroplanes and the ships transmitter. They are also used at a high power at a wide as well as a wide tunable devices. These are the references. In this, 2 links are being shared which shows the animated structure of the TWT, working of the TWT tube. Thank you.